Okay, Module 8, Review and Practice Tests. This will be your study guide. I'm going to work all the problems on this. If you've already taken the practice test, maybe this will help you figure out what you missed. If you haven't, maybe this will give you a good shot at it the first time, right? So now if you take the practice test and you score like a 28%, why are you taking the test, right? The practice test is there for you to understand what you missed, right? What don't you know? So use that wisely. It doesn't count against your grade if you get a 28% in the practice test. Doesn't matter as far as your grade's concerned. That's why it doesn't count. But it lets you know what you need to go back and review before you take the one that does count. So don't take the part one of the test with all the multiple choice if you can't take the multiple choice practice test and do well on that. That's what it's for. It's give you a chance to do well the first time. All right, so use that. All right, let's look at this. I'm going to work all the problems and explain how I do all of these. So if you're having trouble with anything, you can just fast forward to the area that you don't understand if you got this down. Otherwise, feel free to hang along for the ride. Okay, let's look at the first one. Identify the greatest common factor of 9a to the fourth b to the fourth minus 27a third b third plus 18a third b squared. Greatest common factor. So what can we pull out of each term? What is the largest number we can pull out of each term? So first let's look at the numbers, 9, 27, and 18. Well, a 9 will go into each one of them, right? 9 goes in there 3 times, goes in there 2 times. How about the a term? A to the fourth, a to the third, a to the third. Well, all of those have an a to the third. The first one has an a to the fourth, which means there's another a, but at least has an a to the third. How about the b terms? B to the fourth, b to the third, b squared. They all have at least a b squared. The others have a b squared times another b, or a b squared times 2 more b's, but they all have this. So this is the greatest common factor they all have in there. There it is. 9a to the third b squared. Okay, this one they want us to factor completely. So -6. Let's see if there's a greatest common factor we can pull out of there. -6, 18, and -24. We can pull a -6 out of each of those. All right, -6 comes out, which leaves, there's no x. We can't pull an x out of anything. There's no x in this last term. So that leaves x squared when we take a -6 out of that. What about when we take it at 18x? That leaves a -3x. And out of that equals a +4. Factor completely. All of these end up with the x squared term, so this must not be factorable. If it was factorable, we'd see answers go down farther. So since this is as far as it goes, I'm looking for this answer right there, just the 6. So this one has the 6x. It has the same trinomial, but has an x. We couldn't pull an x out of there, so we're looking for that one right there. Okay, the third one here. Factor completely. 20x to the third y plus 30x squared y squared. We have two numbers, 20 and 30. We can pull a 10 out of each of those. We have an x to the third and x squared, so we can pull an x squared. We have a y and a y squared. We can pull a y. So if we pull 10x squared y and we have 20, that means there's still 2. 2 times 10 is 20. X to the third, we pull x squared, there's still an x, because x times x squared is x third. Pull a y, that's it, that's just 1. So 2x is the first term. 30 and 10, that's 3 times 10 would be 30. X squared, that's just a 1. Y squared, so y. Y times y is y squared. So this is what we're looking for. Nope. 10x squared y, 2y, no. 10x squared y, 2x plus 3y. There it is right there. They're very similar. Pay attention, make sure you're getting the right thing there. Okay, let's move on. Factor the greatest common factor of 21x to the third y to the fourth plus 15x squared y squared minus 12xy to the third. So first, the numbers, 21, 15, and 12. Well, the largest number that'll come out of there would be a 3. x to the third, x squared, and x. We can't take anything larger than an x because that's all that this third term has to offer. Y to the fourth, y squared, y to the third. We can factor out a y squared. So 3xy squared. Oh, so it can't be that one or that one. Those are just xy. So if we pull 3xy squared, 3 times 7, x times x squared, and y squared times y squared, plus 3 times 5 is 15, x squared, and x, so it needs an x, y squared, so we don't need anything there, minus 3 and negative 12, so 3 times negative 4 is 12, negative 12. X, that's just 1. Y squared times y. So we need the one that is 7x squared y squared, 7x squared y squared, plus 5x minus 4y. Term by term. Just try to match up and make sure you get that the same. Okay, determine the factors of 4ry plus 4rz plus 8xy plus 8xz. Okay, we don't have a common factor. We can pull out of anything, greatest common factor, because 4 and 3 don't have any numbers in common that we can pull out. We got ry, and this one has xy, and this has xz. Ry and xz don't have anything in common, so there's nothing we can pull out as the greatest common factor. So we need to factor by grouping. Let's put these first ones together. 4ry plus 3rz. What can we pull out of there? Let's see. RZ, all we can pull out will be an R. Okay, and that would leave 4y plus 3z. What can we pull out of this? We can pull a 2 out of the numbers. And then xy and xz, we can pull a 2x. And that would leave 4y plus, pull a 2 out of there, it'd be 3, pull out an x, z. 4y plus 3z, both of these have the same, so that's one term, 4y plus 3z, when we factor that out. And what does that leave? So I want you to see that. Both of these terms, now we got down to 2 terms, right? There's one plus in the middle, so we have 2 terms. That comes out to right there. And now what leaves, when we factor out that from r times that, it just leaves r. And when we factor it out from the second term, it just leaves that. So r plus 2x is what's left when we factor what's in yellow out of both of those. So 4y plus 3z, it has to be one of these. R plus 2x, 2x plus r, that's the same thing, right? 2 plus 3 or 3 plus 2, it still adds up to 5. 2x plus r or r plus 2x, that's still the same thing. There you go. All right. Let's select the factors of 10ax plus 5bx minus 8ay minus 4by. Again, we're going to need to group them. Okay, so 10ax plus 5bx. Well, we can pull a 5 out of there, 10 and 5. A, no. X, we can pull an x out of both of those. And b, let's see. So 5x out of 10ax leaves 2a. And 5x out of 5bx is just plus b. Negative 8 and negative 4. We can pull a negative 4 out of there. Oh, wait, maybe we can pull more. Hold on. A, y, b, y. So we can pull a y. So if we pull negative 4y, factor that out of negative 8ay, that leaves 2a. Negative 4y out of negative 4by is just a b. Okay, we're down to the same thing that we had last time. This and this factor out of the 2 terms, right? Because we have 2 terms. Here's one term, 5x, and then there's the second term. This factors out of both, so we'll factor it out, 2a plus b. And what's left when we factor it out? 5x minus 4y. That's the other factor. 2a plus b, 2a plus b, 5x minus 4y. There it is. All right. Done with page 2. All right, page 3. Factor completely 2x to the third plus 10x squared plus 4x plus 20. All right, so the first thing I see is there's a 2, a 10, a 4, and a 20, and we can factor 2 out of all of those. All right, so that would leave x to the third. We take it. The 20 is just a number. There's no x, so I didn't look at factoring an x out, right, because I couldn't take an x out of the last term. So 2 out of there is x to the third. 2 out of there leaves us a 5x squared. 2 out of there leaves us a 2x, and 2 factored out of there leaves us a 10. So we're down to that. Now the question is, does this factor further? Because there is one of the matches that first answer, but these have more options. So it makes me think perhaps this will factor down even greater. So let's look at grouping. X to the third plus, I'm going to put a bracket of this for now since do it differently. X squared will come out of both of those. Right, so that would leave an x plus a 5. What can we pull out here? There's a plus 2. So that would leave an x plus a 5. So again, here's one term, and they both have an x plus 5. So this factors down to 2, x plus 5. What's left? X squared plus 2. X squared plus 2. There it is, 2, x plus 5, x squared plus 2. That's what we were able to factor it down to. Fabulous. All right. Number 8, identify the factors of x squared minus 4x minus 12. Okay, so it's going to have two factors. And we know it's going to, the first factor is going to be an x and the x, because x times x is the only thing that would equal x squared. Now, the last part has got negative 12. So negative 12, and this has a coefficient of 1. We multiply those together, 1 times negative 12. What are the different factors to get to negative 12? 1 times negative 12, or negative 1 times a positive 12, or 2 times negative 6, or negative 2 times positive 6, or 3 times negative 4, or negative 3 times 4. That's all the possible combinations of numbers that would multiply together to be negative 12. But we want the ones that add together that would equal negative 4. Multiply together to be that, add together to be that. 1 minus 12 is negative 11. Negative 1 plus 12 is a positive 11. 2 minus 6 is negative 4. Oh, that's the one we need. We need the one that added together to be negative 4. So that means we can rewrite this as x squared. Instead of minus 4x, we'll put a positive 2x and a minus 6x minus 12. See, we took that negative 4 and we made it into a 2 and a negative 6. So instead of negative 4x, we have plus 2x minus 6x. That's still the same as negative 4x. We just rewrote it so we can factor it. Now we can do it by grouping. X squared and a 2x, we can take an x out of that, which leaves x plus 2. He's been taught on one. Right, negative 6x minus 12, that's minus 6. And that leaves an x. And negative 6 factored out of negative 12 is a plus 2. Now, again, we got these two terms. So our terms are x plus 2. And that leaves x minus 6 is the other term. X plus 2x minus 6.
Just getting caught up.
There it is, right there at the bottom. X plus 2, x minus 6. All right, here's another one. Factor x squared minus 7x plus 8. Same thing. And 8, what's the factors of 8? 1, 8, negative 1, negative 8. Don't forget those could multiply together.
Because there's ACT aspired testing. So this is a great
2, 4, negative 2, negative 4. What else can we get an 8? Anything else? That's pretty much it, isn't it? So we add these together, we get 9. When we add these together, we get negative 9. When we add these together, we get 6. We add these together, we get negative 6. None of those equal our negative 7. So this must be prime.
Okay. I got
Must be prime.
Well,
it can't factor. because there is no way to
Like I
break out
said,
that middle
I
term
gave one this
into
week,
two numbers that would
so-
add together to be -7 and yet multiply
Yeah.
to be a +8. If you want to test that, you can take these and multiply them together and see if any of those end up with that, but they shouldn't. The signs will end up being different. This one would be a -8 at the end. This would be a +8, but it'd be a -9x. And this one would be a +8, but it'd be a +9x. None of those will equal that -7x. This cannot be factored. That makes it a prime polynomial. But we checked. All right, let's check the next ones here. Factor completely. 3x to the third plus 3x squared minus 18x. Well, the first thing I see is there's a 3, and an 18. Those all have a 3 in common. And I see an x to the third and an x squared and an x. So they all have at least an x, so we'll take that out of there. So 3x factored out of 3x to the third leaves us an x squared. 3x factored out of 3x squared leaves us an x. And 3x factored out of -18x leaves us a -6. Okay. Got the 3x factored out. Now let's factor this. 1 times -6 is -6. So what are the factors of -6? -1 and 6, 1 and -6, 2 and -3, -2 and 3. That's pretty much it. So these add together to be 5. These add together to be -5. I need it to be a 1. These add together to be -1. These add together to be 1. Okay, so this is the one that we need. So this is 3x. And we're going to break this out to x squared minus 2x plus 3x.
Okay, well, here's the deal.
See, we took that x and we made it -2x plus 3x because that will end up with just an x. -6.
So we might as well get this
Okay,
straight up
grouping.
as high as we can so that when you transfer.
So we got 3x out here at the front that we're already factored out. X squared minus 2x. We can take an x out of that, which leaves an x minus 2. 3x minus 6.
I don't know.
3x minus 6. We can take a 3 out of that, which leaves an x, and we'll take a 3 out of that, leaves a minus 2. So this is 3x out front, and then we've got the x minus 2 that's in both of those, x minus 2, and that leaves x plus 3, x plus 3, 3x, x minus 2, and x plus 3. Oh, there it is. 3x, x plus 3, x minus, different order.
Right.
Again, you multiply 2 times 3 or 3 times 2. They both equal 6. So it doesn't matter what order we multiply them in. Those are the same factors right there.
Anna, you're on
X plus 3, x minus 2. Fabulous. Okay, number 11. What are the factors of 3x squared plus 10x plus 3? Okay, 3, 10, and 3. Nothing factors out of that. X squared, x, and there's no variable. So there is not a greatest common factor to take out of this one. So we've just got to break it down. So the first coefficient times the last one. 3 times 3 is 9. So the factors of 9 are 1 and 9, -1, -9. 3 and 3 are -3 and -3. That's it. Nothing else can multiply to be 9. And when we add these, 1 plus 9 is 10. Oh, that's the one we needed. We needed a plus 10. So let's rewrite this to be 3x squared plus 1x plus 9x plus 3. Okay, see, we took that plus 10 and we made it a plus x plus 9x because that's what adds together to be 10 and multiplies together to be 9. Because we need to multiply 3 times 3.
Well, yes.
The 9, that's the number we're looking for. This one's a -6
Gravity is a force.
because this was 1 times -6. See, the coefficient was a 1. You got to multiply that first coefficient times the last number to figure out what number we're looking for. All right, so now that we've rewritten this, let's factor by grouping. 3x squared plus x. They have an x in common, which leaves a 3x and just a 1. Because when we factor x divided by x, it just leaves 1. Now we've got a 9x plus 3. We can factor a 3 out of there, and that leaves 3 out of 9x equals 3x. 3 out of 3, 1.
something with a bigger
First
mass,
term,
then, oh my
second
goodness,
term,
got more
we can
versions
factor a
than I
3x plus 1 out of both
do.
terms.
That's more mass.
3x plus 1. And it leaves x
Okay.
plus 3.
Newton's first law. That shouldn't be
So
too hard.
3,
Get that
there's
done,
a
and
3x
maybe
plus
you can
1,
get
x
the
plus 3.
first
There
law
it
and
is.
the second law done in class.
There we go. That's the number 11.
Let's try.
Let's move on to
see
number
how well
12.
we get done in class.
Determine the factors of 5x squared plus 29x minus 6.
Okay.
Again, first and
Ethan,
last.
are you there?
So we're looking for negative 30.
Okay, Ethan, now
Okay,
I
so
went
negative
over
30.
3.04
What
in the
all will make
last
negative
video
30?
on
Well,
Thursday. What
1
do you
and
think is
negative 30 or negative 30 and
Nope.
1. What else equals 30? 3 and negative 10, negative 3 and positive 10, or 5 and negative 6, or negative 5 and positive 6, or, oh, we missed
Good luck,
2
Erica.
and negative 15 and negative 2 and positive 15. Well, is there any others? 30's got quite a few of them, doesn't it? All right, so when we add these together, 1 plus negative 30 is negative 29. We're looking for positive 29. Oh, I wrote that
Okay.
same numbers again right there.
Okay, Erica, you're
1 and negative 30, so this would be negative 1 and positive 30.
So we
Whew.
just had a test.
Make sure I get the
where
right
we
numbers
knew
down.
you hadn't
Negative 1
started.
plus 30 is positive 29.
And
This
you
is the ones we
need
need right
to
there. We don't have to go through the rest of those.
Do the test
So this could
right
be
before. So you need
5x
to do
squared.
United Kingdom
Instead of plus 29, we'll do
18.
minus
Now, didn't we already do
1x
that on Thursday?
plus 30x minus 6. So
Okay.
we change that plus 29 into a minus 1 plus 30. Same thing as plus 29. So factor by grouping.
Okay, yeah. So
5x squared minus x. We can pull out an x, which leaves 5x minus 1.
All right, do the review.
Right?
Let me know if
5x
you have
minus
any
1.
questions on the review.
30x minus 6.
Okay.
30x minus 6. What can we pull out of there? All we can pull out is a 6, which leaves 6 out of 30x equals 5x. 6 factored out of negative 6 is negative 1. Two terms. Both of them have a 5x minus 1 that we can factor out, which leaves an x plus 6. There is our factors. 5x minus 1. Oh, looks like it's the first one. The other ones don't match. 5x minus 1, x plus 6. Moving right along. Number 13. Which polynomial is a perfect square trinomial? Okay, so if it's a perfect square trinomial, we could take the first term, take the square root of that, take the square root of that, and then the middle term will be double what those two are multiplied together. So the first term on this one, 6x squared, would be a 6x
You are a unit behind, Timothy.
and a 6x.
We just took a test.
Negative
You
9
haven't even
would
started.
be minus 9. Would have to be a negative 3 and a positive 3. Oh, that doesn't work. That's not a perfect square because it has to be the same number. The only way you can get a negative number would be to multiply a negative times a positive. So it can't be that one. Same thing here, negative 49. That has to be a positive 7, negative 7. We've ruled out 2. It's got to be one of these two. These are the ones that have positive numbers at the end. So 25b squared. Oh, not a 2. That would be the same as a 5b times a 5b. 16 is 4 times 4. It's also negative 4 times negative 4. And since this is a negative, that means it has to be a negative. So it could be that one, or it could be, let's look at this, 2x and 2x would make 4x squared. 9 and 9 is 3 times 3 would make a 9, or it could be negative 3 times negative 3. So now, which one is it? These are both potentials. But remember, when you multiply the first term times the last term, and you do it twice, because here's the negative 4. Let me show you there. So that negative 4 is there twice. And the 5b is there twice. So we're going to multiply those. When you distribute, you take 5b times negative 4 for the middle term and negative 4 times 5b. So what is negative 4 times 5b? That's negative 20b. And this one's also negative 20b. And when you put those together, negative 20 plus a negative 20,
So you're on
negative
3.04A.
40b, it's got to be that one.
Well, if
This
you
one,
do that,
2x times negative 3 is negative 6x. And then the other one is also negative 6x. And when you put those together, it'd be negative 12x. We don't have a negative 12x. We have a negative 6x. So this one factors to be 5b minus 4 times 5b minus 4, or 5b minus 4 squared. That's why this is called a perfect square trinomial, because the factors, that's a b, is 5b minus 4 squared, perfect square. All right, select the factors of x squared minus 16x plus 64. All right, and it wants to know which of those it could be. So we're looking at perfect squares. Does that mean this is probably a perfect square? If it is, there's only two options that are perfect squares. These are not. Let's see if this is a perfect square. If this is a perfect square, be x times x. 64 times 64. I mean, 8 times 8 equals 64. So, I mean, what is 64 square root? But since this is a negative, it'd be negative 8 times negative 8. Is this the factors? If so, remember the negative 8 times x? Negative 8 times x, so it'll be negative 8x times 2, because there's two of them. Negative 16x. Oh, it is. This is a perfect square trinomial with the factors of x minus 8 times x minus 8. All right. We could have also done the same method that we used on the others. If we wanted to, we could have found which number makes a 64. We listed all the options. We'd have broke it out into the two. We'd have factored by grouping, and we'd have ended up with the exact same answer, x minus 8, x minus 8. If we can recognize the perfect square pattern, it saves us time. Perfect square pattern says you have the same factor twice, whatever equals itself to be x squared, whatever equals itself to be negative 64 or positive 64, using the sign of the negative one. And then you multiply those two terms together and double it. And that would be a perfect square trinomial. So if you can recognize that, it saves you from having to go through the other work. Let's test this one to see if we can do the same thing, since we're in the perfect square section. Identify the factors. So 4x squared would be 2x times 2x, right? That would be the two numbers that multiply together to be 4x squared. 25 is 5 times 5, and it should be a positive to be that middle term. So plus 5 plus 5. Okay, so what is the 2x squared times 5? That's 10x, right? And if we have two of those times 2, we should have 20x in the middle, positive. We do. So this is 2x plus 5 times 2x plus 5 right there. Or 2x plus 5 squared, because it's times itself. 2x plus 5. All right. Number 16. Determine which polynomial is a difference of two squares. Difference. There's the word sum that we use when we add things. There's the word difference we use when we subtract things. So there's no way this is a difference because it's got plus. And there's no way this is a difference because it's got plus. If it's a difference, it has to be subtraction. Two squares. X squared is x times x. What do we multiply by itself to get 14? Yeah, that's not a nice real number. It's not a whole number. That is some fraction, some decimal. It's not going to be that. This is x plus 7, x minus 7. That'd be the factors. The difference of two squares. X squared is a square, 49 is a squared, and we're subtracting it. It's a difference. We subtract this square from that square. That's our answer. And what are the factors of that one right there? I just did that. Right? When it's the difference of two squares, the shortcut is you write the two squares, you write the x and the 7 and the x and the 7 because it's a difference of two squares, and you make one positive, make one minus. That's the shortcut. If you recognize you have the difference of two squares. There you go. One positive, one minus. Okay, factor completely. Well, looking at this, 36 is a square, right? That's 6 times 6. 25x squared is a squared. 5 times 5 is 25, x times x. So we have the difference of two squares again. We have 5x and 6. And since this is a difference, we make one positive. I bet make both of them positive. Make one positive and one negative, and that is the factors. So 5x, one positive, one negative. Got to choose the one that has the positive and the negative. See, the shortcuts make this so much faster when you recognize if you have the difference of two squares, or if you recognize you have a perfect square trinomial. Just saves you time. We could do all of them by listing over on the right all the factors, which ones add together to multiply to be that. We could do all of these that way, but we want to take the shortcuts when we recognize they're there and save us some work. So, all right. Number 19, some steps to rewrite the expression x to the third minus 9x plus x squared minus 9 as a product of three factors are shown below. So here's what they did. Step 1, they wrote it down. Step 2 is they rearranged to put it in standard order, standard form, right? X third, x squared, x to the 0 or 1. There's no x, right? So they put it in standard form. They put them in the proper order. Then looks like they did the grouping, right? They did factor by grouping because of those two terms. They pulled an x squared left out, which left an x plus 1. And then they pulled a negative 9 out of those two terms, and it left an x plus 1. So what's the next step? Oh, the next two steps. Well, then this is a term and this is a term. So we pull those out, x plus 1. Oh, x plus 1. They all have the x plus 1. The other one would be x squared minus 9. Okay, so it's not that one. It's not that one. X squared minus 9 is our other term. Then the next step beyond that is x squared minus 9 is the sum. I'm sorry, not the sum. This is the difference of two squares, right? X squared is a square, x times x. 9 is a square, 3 times 3. And it's a difference. We're subtracting a square from another. So we would be able to factor that into an x and a 3 and an x and a minus 3. No. Up, look at there. One's positive, one's negative, and then we have the other factor of x plus 1. One positive, one negative, x plus 1. Okay. Number 20. Which shows 54 squared minus 46 squared being evaluated using the difference of squares method? Okay, this is two squares because this is 54 times 54, right? 54 squared. Doesn't matter what the number is. This is 46 times 46. This is the difference of two squares. So we know that that's going to equal 54 plus 46 times 54 minus 46, because that's what this is. One's positive, one's minus. Take the two factors that you would square together. So that shows this 54 plus 46 and 54 minus 46. 54 plus 46 is 100. 54 minus 46 is 8, which is what they did. And 100 times 8 is 800. So 54 squared minus 46 squared equals 800 through these steps, shortcuts. See, this one, they went ahead and they took 54 and they squared it times itself, and it's 2,916. And 46 times 46 is 2,116. And then they did the plus and the minus, but that's wrong. That's wrong because you wouldn't have it plus and minus. You do the factors plus and minus, not what the square equals. So that's totally wrong. This one, they just did it the old-fashioned way. They actually figured out what 54 times 54 was. It is 2,916. This is 2,116, and the difference is 800. This is a correct formula, but it's not using the difference of squares method. Ours doesn't need a calculator. You're going to need a calculator for 54 times 54 or 46 times 46 or some long division, all right? And this one is taking 54 minus 46 squared. It's not. Remember, one is a positive, one is a minus. They're not both minus. So that one doesn't work. This uses the difference of squares method simply. All right. Now it wants to know what are these zeros of f of x equal x squared plus 5x plus 6. The zeros. So that means when does this equal 0? F of x is the same as y equals. So when does the y equal 0? When does this equation equal 0? Easy way to do that. First, let's factor it. Okay. X squared plus 5x plus 6. This is a 1 coefficient. 1 times 6 is 6. So that means it's either 1 times 6 or negative 1 times negative 6 or 2 times 3 or negative 2 times negative 3. It's one of those. Add these together. That's 7. This is negative 7. This is 5. Oh, that's what we wanted, 5. So it's 2 and 3. So this is the same as x squared plus 2x plus 3x plus 6. See, rewriting it with the 2 and the 3, 2x and 3x instead of the 5x. Now we can solve by grouping. We can take an x out of the first term, leaving an x plus 2. And we can take a 3 out of the second group, leaving an x plus 2. So that means this is x plus 2 times x plus 3. Okay, so that is the factors of this. So if that equals 0, if we multiply x plus 2 times x plus 3 and it equals 0, if we take any two numbers and we multiply them together and it equals 0, what do we know about the numbers? We know something right away. We know that either the first number is a 0, and it doesn't matter what the second number is because 0 times anything is going to equal 0, or it means the second number is a 0, and it doesn't matter what the first number is because anything times 0 equals 0. It could both be zeros for that matter, but we know one or the other has to be a 0. So that means x plus 2 could be 0, or x plus 3 could equal 0. Either one of those. So what do the x equal if it's x plus 2 equals 0? Subtract 2, x equals negative 2. Negative 2 plus 2 equals 0. Subtract 3, x equal negative 3. The zeros of this are negative 2 and negative 3. Right there. Because if you substitute negative 2 into that equation, it will equal 0. Negative 2 squared is 4. Negative 2 times 5 is negative 10. 4 minus 10 is negative 6. Plus 6 equals 0. Same thing happens if you put negative 3 in there. That will again equal 0. So those are the zeros of that quadratic equation. Numero 22. How many do we have here? Oh, we got just a couple more pages. Getting towards the end of it here. All right. A polynomial function can be written as x minus 2 times x minus 3 minus x plus 5, because those are written in factored form, right? Those are the three factors. If we multiply them together, they'd be a polynomial. What are the x-intercepts of the graph of this function? Oh, the x-intercepts, like on a graph, when it's right here on the x, if it was right there, what is the y? The y is 0. So that's the same thing. The x-intercept is another name for the zeros. Right, the zeros of the equation. So x-intercept are zeros. So if it's x minus 2, what does that have to be for that to be a 0? X would have to be a 2, right? Because 2 minus 2. Or 3 minus 3, or negative 5 plus 5, right? Because x plus 5 equals 0. Subtract 5. X equals negative 5. You can set any of these equal to 0 and solve it. And the answers are 2, 3, and negative 5. So the x-intercepts, the zeros, would be when the x equals this. So when the x equals 2, the x equals 3, and the negative 5, x equals negative 5. Those would be right there. The zeros, we would just say the zeros are 2, 3, and negative 5. But we want to know the x-intercepts, we have to give the coordinate of the x-intercept. That's the only difference. Same numbers, but you got to put that comma 0, comma 0, comma 0 for it to be the x-intercept. All right, but we use it by starting with these zeros of that function. Oh, and for those that bothers you, zeros is ES. Don't want to get your English side all excited here. The zeros. All right, so this graph shows two polynomial functions. We got f of x, which goes right down here. Let me highlight that so we don't get it confused. F of x. That's f of x. And then g of x is the parabola shape. Which goes down. Back up. So there's g of x. Which is true about the graph above? So it says that g of x is an odd degree polynomial with a positive leading coefficient. Or f of x is an odd degree with a positive leading coefficient. Or is g of x even with a negative, or f of x even with a negative leading coefficient? Well, this is what do we know about graphs. What does it mean by an odd degree polynomial? That means it's an x to the third, or an x to the fifth, or an x to the seventh. It means that the exponent is an odd number or an even number for an even degree polynomial. Positive leading coefficient means the biggest one. If this is x to the fifth minus x to the seventh plus 5, the biggest is the seventh, so it would be a negative leading coefficient. You have to look at the largest exponent, right? So this would be an odd with positive. Okay, so the shape of the graph, f of x starts low and goes back up, right? It's got this kind of shape. This is the shape of an odd polynomial, odd degree polynomial. An even one is like a parabola, right? We looked at with the x squared is even, 2 is an even number, and it's going to look like that. So anything that's even is going to have both ends going the same direction. The ends are going the same direction if it's even. If it's odd, the ends are going to go different. This end's going down, that one's going up, or it could be up and then down, right? But they're going to go different directions if it's odd. The positive or negative tells us on the right side, is this pointing to the positive numbers or is it pointing to the negative numbers? Right? And it's all determined by the largest exponent. Is it positive or negative? Since this graph is going positive and this is going positive, these are both positive leading coefficients, which means it can't be either one of these choices because f or g, neither one is a negative because they are both going towards positive numbers on the right side. The question is, which one of these is an odd degree? Is it g or x? G is the parabola. It has to be an even. So f of x is the odd because it has more of this pattern. The left side's going down, the right side's going up for a positive one. This is for a negative one, for a positive one. So that's what we see. So f of x is an odd degree polynomial with a positive leading coefficient. See, we know a lot about that graph without seeing the equation. And we know that the 0 is right there, which is the x and the y intercept. All right. This looks to be, oh, not quite the last question. What's our last question? All right, we got 2 more. Which of the following is the graph of f of x equals x squared minus 5x plus 4? Well, let's see. We have 4 choices here. And what are the major differences? Let's see. The first difference I see is the y-intercepts. This one's right there. That one's right there. That one's right there. That one's right there. What is those y-intercepts? This is a y-intercept of 4. This one's at negative 4. This is a y-intercept of negative 5, and that's a positive 5. Okay, that enough right there is enough to tell the difference. And the fact that they all have different y-intercepts, if we just know what the y-intercept of our equation is, that will tell us which one it has to be.
Where you have to calculate
We could also look at the zeros. This has a 0, 1, and 4. This has a negative 4 and a 1. This one's a 1 and a 5, and it's a negative 1 and a 5. So we could take this and we could factor it into its two factors and figure out the zeros and tell which one it is. But since they all have different y-intercepts, that should be the easiest because what is the x right here? X 0, because if x was 1 or 2, it'd be over here, right? It wouldn't be on the y-axis. So when x equals 0, so f of x equals 0 squared minus 5 times 0.
The one you're on.
Minus 5 times 0 plus 4. So f of 0, we'll put 0 in for x.
The equation is very much like
0 squared minus 5. So 0. What's a negative 5 times 0? 0. 4. So f of 0 equals 4. The y-intercept for that equation. We can easily see that it's the only thing that doesn't have an x. It's the constant at the end of the equation. It's a plus 4. It's going to have a y-intercept of plus 4. So it has to be this graph right here, which its circle got stuck down here. So this one, it's the only one that has a plus 4. Now we know the zeros are at 1 and 4. So we know the equation is x minus 1 and x minus 4. Because 1 minus 1 minus 1 would be a 0, or a 4 minus a 4 would be a 0. So that is what this equation breaks out into the factors right there. Just because we know now what the graph looks like. Okay, last one. Yay! All right. Number 25. Our last question. Which of the following functions best represents the graph? Okay. Again, let's start out by looking at that y-intercept. Negative 4. All right. These are the only terms that don't have an x, because if we put in a 0 for x, those are all going to 0 out. So we know right away it's not the first one, and it's not the third one, it's not the fourth one. It has to be one of the first two. Okay? What else can we learn? Okay, this has 1, 2, 3, which means it must be an x to the third. These are both x to the third. So we have at least an x to the third since it's at 3 zeros. We're going to need to factor these to see which one has those zeros. But we only have to do 2 of them. Let's do the first one.
The other one is for 4.
X to the third plus x squared minus 4x minus 4.
Like magnets.
May not even have to do both of them, right? So what factors out of x to the third plus x squared?
So
X squared, so that leaves an x, and that leaves just a 1. Negative 4x minus 4. We can factor a negative 4 out of that. So negative 4 divided negative 4x is just x. Negative 4 divided by negative 4 is a 1. 2 terms, x plus 1. X squared minus 4. X squared minus 4. This will factor. These are both squares, 2 by 2 and x times x. So this is the difference of 2 squares. So we know this is the x plus 1 right there. This has to be x and 2 and x and 2. One of them be positive, one will be negative. Which means the zeros, x plus 1 equals 0, right? So that means this is negative 1. This x 0 is negative 2, and this one's 2. So that is the zeros for this equation. 1, negative 2, and 2. What do we have here? 2, negative 1, negative 2. Those match up. This must be our equation. Because it has the right zeros, and it has the correct y-intercept. Another thing we could check would be the vertex. Oh, we might have done that. I might say, but it looks like the vertex might be off just a little bit. But let's see, the vertex. No, that's for a parabola. We can't do the vertex. This is not a parabola. The formula only works for the ax squared plus bx plus c, and this is not a squared. This is x to the third. So we got to do it this way. Let me go ahead and double check this. X to the third plus 4x squared minus x minus 4. For those of you, just curiosity is getting the best of you. So we can pull an x squared out of there, which leaves x plus 4. Over here, we can pull, all we got is a negative 1. And that leaves an x plus 4. So that gives us x plus 4 and x squared minus 1. This, again, is the difference of squares. 1 times 1 and x times x. So this is x plus 4, x plus 1, x minus 1. But the zeros here is negative 4. Negative 4 plus 4 is 0. Negative 1 or positive 1. That does not match our graph. Our graph is 2, negative 2, and negative 1. So that is the correct answer. All right. Fabulous. So that is the practice test. If you struggle with any of those, back it up and look at this part again, right? If you haven't taken the test yet, and then you do take it and you miss some that you can't figure out why it's wrong, come back and look and see what I did on those problems, and that may help you. If you're still struggling, get with me. Hey, Mr. Brock, I need to review a couple of questions on this so I can make sure I know how to do those, because I'm not understanding this. And, we got the test coming up. I need to take the test. And before I take the test, I want to know how to do this so I get this right. Good idea. All right. So that is it. Do work you can be proud of. See you next time. Watch my test video before you take the test also.